Hi everyone, and welcome to this session that I put together on classifiers. So a classifier is a machine learning algorithm that is used to categorize data, essentially. I think classifiers are fantastic to help you get started in understanding how machine learning and AI works. So a lot of the concepts that are used in classifiers, classifiers are quite simple, but the concepts extend into much more complex AI and machine learning processes like agents and workflows and things like that. So classifiers are a great way to get started understanding the fundamentals of AI. I don't think it makes sense to dive in to start building an AI agent right away if you don't understand some of the more fundamental concepts. And if you want to get your feet wet, classifiers are a great way to do that. They're a great way to learn those really, really fundamental concepts. So in this session, I'm going to run through a very simple example, and in future sessions we'll do something a little bit more, not complex, but a little more real worldly, let's say. We'll use a classifier to detect spam. But in this first session that we're working on today, I'm going to use an example that's not related to that particular problem. It's going to be even simpler than that. So I want to really focus on the concepts rather than getting kind of muddied over with a complex kind of solution that uses a lot of lengthy data. Let's just keep it simple for now. So this session is standalone. You could just watch this part one classifier session that I'm going to do today, or you can continue on with the code in future parts. But you can this first session is standalone. So what I'm going to do is I'm going to explain how classifiers work. And if you want to continue on with getting into some code, then there's going to be future parts. So what is a classifier? It's a machine learning algorithm that automatically assigns items of different types into discrete categories. So basically takes items and it just puts them into categories, very simply. But it requires training to do that. So it needs to know ahead of time what those categories are. And you can think of like a classifier as a pipeline. There's a few steps to this pipeline. The first step involves training data. The second step is vectorization and feature extraction. The third step is model training and evaluation. The fourth step is testing. So training data is just raw data that we're going to use to train the model. Basically, this data is going to be used to tell the classifier where to put these different things, right? So we have a set of things, whatever they are, and we want to put these things into boxes, right? So we have to tell the classifier what boxes to put these things in first. And once it learns how to put these different items into different boxes, when you use the model in the future, after it's been trained, it'll be able to do what you want it to do, essentially, without having you intervene. So that's developing the training data. The second step is the vectorization and feature extraction. So vectorization is just the process of converting words into numbers, into vectors. Machines don't understand words, so you have to vectorize all of the data, and you have to extract what's called features. So features can be just words, they can be groupings of words. In our case, it's just going to be words because we're going to take a very simple example. The third step is model training and evaluation. So training the model with these vectors that we've developed in step 2. So telling the model that this item goes in this box, this next item goes in another box, and so forth. And then finally testing. So 4 steps. If you're looking at a classifier more granularly, there may be a few more steps than that, but in general, these are the 4 steps. So the first step is to prepare training data. So today we have a very simple example. We're going to take the example of vegetables and putting vegetables in the correct box. So carrots go in the carrot box, broccoli go in the broccoli box, and onions go in the onion box. So once we train the model, the classifier should be able to do this seamlessly. It should be able to do this without any human intervention. And that's the core principle of training, is to tell a model, an AI model, an algorithm, that this is the way we want to do things, and that going forward, it will do it automatically without any human intervention. So we have a Python dictionary in this case, very simple. we have two arrays within that dictionary. One is the actual vegetables, the data, carrot, broccoli, and onion. And the second array is just the labels that we want these vegetables to be assigned to. So once we have our data set ready, the next step is to vectorize this data set. Vectorization and feature extraction. So vectorization is just converting this data set, which is a Python dictionary that contains text and labels, so a collection of different vegetables and the labels associated with these vegetables, and then converting it into a matrix, a vector matrix. So we have this data set, we run a function called fit transform to convert that into a matrix. Fit is just learning the vocabulary, learning the different words within the data set, and then transform creates the matrix. So on the right-hand side, the left-hand side, we have our data set. The right-hand side, we have the matrix. Every row is a different, what's called a document. This is lingo that's used with classifiers. It just indicates a different data set within the matrix. And every column is what's called a feature. So you can see for the first document, only carrot is available in this document, not broccoli or onion. In the second one, only broccoli is available, not carrot or onion. And then the final one, broccoli and carrot are not available, but onion is. So this is our feature matrix, and it uses something called term frequency inverse document frequency, which is just assessing the probability, the weighted probability of all of the different features within the document, and also the rarity of those features. So when I say features, I mean words within the data set. So step 3 is to train the model. So we develop this matrix of labels and the vegetables and the corresponding labels, the original data set. We vectorize that data set, and now what we're going to do is divide the data set into two, 80% for training and 20% for evaluation. So 80% of the data set will be used to actually train the model to classify as we want going forward, and 20% would be used to evaluate. Now this data set that I have in this example is extremely small. It only has 3 rows in it, so you wouldn't use the 80-20 split in this particular case, but as the size of the data set grows, normally we'd have a data set that's much larger. It would have minimum tens of thousands of, hundreds to tens of thousands of rows. So when you get to that point, 80-20 makes sense. The 80% is used, as I mentioned, to train the model, and 20% is to evaluate, to give sort of some feedback on what is the accuracy of the model after you've trained it. So the last thing you would do is test the model. Testing the model would just be feeding in one of these 3 different types of vegetables and seeing if it classifies the vegetable correctly by assigning it to the right label or the right box. We're going to look at a slightly more complex problem, as I mentioned, the spam filter problem. This problem here is extremely simple with the vegetables. Like, you would never use something like this in the real world because it has a very tiny data set. It's not very useful, but it's really just to understand the fundamental concepts of classifiers, and then you can take it to the next level and actually create something that's useful. So the spam filter problem is a pretty interesting one because you can actually use that in the real world. You can build a spam filter as an add-on to like a service management solution or an email solution. I mean, there's a lot of spam filters that already exist, but there's other ways you could sort through spam in different contexts in a business environment. So it can be very useful, and it can be extended to all kinds of other different types of problems. So thanks for listening to this classifier description or rundown. I tried to make it as simple as possible for you guys to understand the concepts of classifiers, and then you can take it to the next level when you want to apply this into the real world.